Today, about 400 million people, or 8.3% of adults around the world, are currently considered diabetic. Diabetics must test their blood every day to measure their blood sugar level, which can become a huge mental burden. To alleviate this mental burden, the Quantum Beam Science Center developed a palm-sized blood sugar sensor. What is this sensor like?
We
have accumulated laser technologies through cutting-edge development for over a decade. By putting many of these technologies together, we successfully developed a fingertip-sized laser system and used it to develop a palm-sized blood sugar sensor.
初めて手のひらサイズぐらいの血糖値測定器が開発できたと。
Glucose is what causes diabetes. Glucose dissolved in the blood is called blood sugar, and its concentration in the blood is called the blood sugar level. Mid-infrared light is attracting considerable attention as a means for measuring the blood sugar level. The advantage of mid-infrared light is that glucose strongly absorbs it, yet biological substances other than water and alcohol do not. Focusing on this specific feature, the research group successfully generated a mid-infrared laser with a peak power about 1 billion times stronger than the mid-infrared light used for nickel-chromium wire heaters. The major outcome of this research is the ability to measure blood sugar levels using a very small device compared to a conventional blood sugar sensor without drawing blood. I'm irradiating a mid-infrared laser into my middle finger and measuring my blood sugar level without taking blood. Mid-infrared light is directed into the fingertip and particles of light are absorbed by glucose. Particles of light that were not absorbed by glucose are reflected by the skin and enter the detector. By measuring the difference between the incident and reflected light, the blood sugar level can be calculated. Future studies include clinical tests of the system and its use on healthy people for preventing diabetes and general health management. Chief Researcher Yamakawa is diligently working on development of the system towards early practical application. There are many people in the world who are suffering from frequent blood tests. To ease this burden, we would like to practically apply and commercialize the system as soon as possible. It certainly is important to do research that will become useful in 10 or 20 years. But our focus is on research and development that would help people today or tomorrow using our laser technologies as the mainstay. It is our desire to continue working on research that helps people in a wide range of fields.